Now we are going to consider the remaining two types, type 2 and type 3. Type 2 domain is a solid region where x values are bounded by two surfaces, u1 y comma c and u2 y comma c, and your y and c values are in domain D, and domain D is in the YZ plane. So basically we project the solid E onto the YZ plane. Now in this case, the triple integral of f of x comma y comma c dv over the solid E equals to double integral over the domain D. We have the inner integral that corresponds to the x variable, and the limits of the inner integral are u1 of y comma c and u2 of y comma c. Finally, you should have dA. Now this dA is an area element on this domain. Now the last type is type 3. So if you have a type 3 domain, then your y values are bounded by two surfaces, so left and right. The right surface is u2 of x comma c, and the left one is u1 of x comma c. And then what we do is we project this solid E onto a domain D, and your x and c values are in D. And your domain D is on the xc plane, on the xc plane. Now in this case, the triple integral of f dv over the solid E equals to double integral over the domain D. We have the inner integral, and now my first variable of integration should be y, then dA. And what are the limits of y? Y goes from u1 of x comma c to u2 of x comma c. Okay. Again, these two types are very similar to the previous one. In type 1, we project the domain, the solid region E onto the xc plane. In type 2, we project the solid E onto the yz plane. And finally, in type 3, we project the solid E onto the xc plane. Next, we can try this example. So in this example, we want to set up an integral to evaluate the volume of a solid region E, and your solid region E is bounded by four planes: x equals 0, y equals 0, c equals 0, and the plane 2x plus y plus 3c equals to 6. Okay. First, we want to draw this domain. we have x, y, and z axis. X equals 0 is the yz plane, y equals 0 is the xz plane, and z equals 0 is the xy plane. Now to draw the plane 2x plus y plus 3z equals to 6, we want to identify the x, y, and z intercepts. To get x-intercepts, substitute y equals 0 and z equals 0. Then you have 2x equals to 6, therefore x equals to 3. So this is 3, 0, 0. To get the y-intercept, substitute x equals 0 and z equals 0. You will get y equals to 6. 0, 6, 0, and finally c intercept equals to 2, because 3c equals to 6, this is 2. Now we have this plane, and our solid E is this tetrahedron. Solid E is this tetrahedron. Now in this problem we want to project this solid E onto the YZ plane. So in other words, our domain D is this part. The domain D should be something like this. This is our domain D. Let's set up the integral. The volume equals to triple integral of 1 dv over the domain E. Now first we have the double integral over the domain D, and then we have the inner integral that corresponds to the x variable, because we want to project this solid E onto the YZ plane. So my first variable of integration should be x. The lower limit of x is given by the YZ plane, which is 0. Upper limit of x is given by the plane, and the equation of the plane is 2x plus y plus 3c equals to 6. Let's solve for x. You will get x equals to 6 minus y minus 3c over 2. So then the upper limit of this inner integral should be 6 minus y minus 3c over 2. Okay, now we want to figure out the limits of these two integrals. To find those four limits, let's consider this domain D. Now if I consider an area element, then the two outer integrals, the limits of the two outer integrals can be written like this. 1 dx. Let's say this is dc dy. So this dA equals to dc dy. Now this y-intercept is 6, and the equation of this line is y plus 3c equals to 6. Now my middle integral corresponds to the c variable. Therefore, we want to express the limits in terms of the y variable. The lower value of c is given by the y-axis, so it should be 0. Upper limit of c is given by the line y plus 3c equals to 6. Now if you solve for c variable, you should get 6 minus y over 3. Finally, the limits of the outer integral are 0 and 6. And now if you want, you could do the same thing by projecting this solid E onto the xz plane.